Hey there, my name is Eric Blum. I'm a software engineer here at Enertiv, and I'm here to tell you why non-sensor data is critical to smart buildings. One of my big jobs at Enertiv is to look through the billions of hours of machine performance data that we have and find actionable insights for our operators. But if we're just looking at the sensor data by itself, it's very difficult. We have too much data to look at manually, and without the context to tell us what equipment this is, how it should be operating, we just can't really say. If I showed you this graph, could you tell me if this part is bad? Is the spike here bad? We just can't know. We're blind to the optimal configuration of this device, so we don't know how this equipment should be running, so we can't really say for sure if this is the right way to do it. This leads to false positives, which is kind of antithetical to how smart building should work, because it erodes the confidence and wastes the time of your operators. So this is a big problem, but how do we build this context about the sensor data? So that's what non-sensor data comes in. The approach of gathering non-sensor data is to gather stuff like the nameplate information. What size of pump is this? What size of elevator motor is this? Collect the operations manual. How do you actually fix it if it goes wrong? Collect the maintenance schedule. When should it be going down? When should it be coming back up? Where is this located? Where's the picture of it? So we can actually see where it is. When you collect all that information, now you can make much more specific insights about the sensor data that you see. Because now you know what's the optimal based on what kind of equipment it is. You can say when it really goes down. This is fast and scalable because you don't have to rewrite every model you do, every new building you go to. You can just build a model based on this is how a pump should work, these are how elevators should work, and you're able to say with high confidence that they're going down or they need maintenance. You're also able to benchmark your equipment. Which equipment are underperforming? You don't know that if you don't know what kind of equipment they are. So here we have an example where we've combined the sensor data and the non-sensor data. So we're able to say, because of the non-sensor data, that this is a sump pump Wilden P8, it's 5 years old in the elevator shaft. Now, just this sensor data by itself, it might be hard to say what's going on. But now we know it's a sump pump. It goes online, but stays on. Now that tells us, it could be a very bad thing. It could be the basement flooding. And that could lead to, massive damage to your building. So we're able to send a very specific insight with high confidence directly to the operator, and they can fix it right away. Now, in this case, it turned out that they had manually overridden the automatic operation of the sump pump. So the basement wasn't flooding, but the pump was running without any water in it, which causes damage to the pump. Because of what we knew about how the pump should work from the non-sensor data, we were able to give a very quick, very high confidence alert to the operator, and they were able to save their equipment before it broke down. I hope this shows how important it is to combine your sensor data and non-sensor data to really complete the picture. Thanks for listening. My name is Eric Blum.